test. Unfortunately. You don't have to be silent, but... Alright, so we did where we can factor the polynomials. Now we're going to look at trying to solve the equation when you can't factor. Alright, so some very smart mathematicians came up with this way called the rational root theorem. Alright, and what is a rational number? Fraction, right? Because you have a ratio, right? So it says if you have a polynomial and it has integer coefficients, every rational root of your polynomial will look like this, p over q. Okay? P is the factor of the constant term. Okay? The constant term is back here, right? That is the term that doesn't have a variable on it. Okay? And then the q is the factor of the leading coefficient. So that is the leading term, coefficient with the leading term. All right? So what we're going to do is we're going to list out the factors for the two of those numbers and try and come up with possible factors to test. All right? So this theorem does not guarantee your answer, but it gives you possible answers that you can check. So it kind of helps you narrow it down. Okay. All right. Find the rational roots of x cubed minus 3x plus 2. Okay. So my, what do I call it? That is the constant term. What would the constant term here be? 2, right? Now, what are the factors of 2? 1 and 2. Now, don't forget the plus or minus. Plus or minus 1 and plus or minus 2. Okay. Now, what is my leading coefficient? 1, right? Now, factors of 1 are 1. Okay, so now I need to come up with possible rational roots using these numbers here. Okay, so possible roots. Bless you. So what you're going to do, all your roots are going to be q divided by q. Okay, so you're going to have 1 over 1, which is 1, and then you have 2 over 1, which is 2. So how many possible roots do you have you can test? How many? 4. So you have 4 possible roots to test. Yeah, so you have positive 1, negative 1, that's 2. You have positive 2, negative 2, that's another 2. Okay? So, yes. So that goes with the constant term, right? 2 is the constant term because it doesn't have a variable. It's the leading coefficient. So that's the number in front. That's just how the theorem works. Well, you don't have to list P and Q every time. You just have to list the numbers that they represent. All right, now, if these numbers work, right, if they are roots to my equation, when I plug them in, what should I get back? 0, right. So I'm going to test 1 first. So f1, I get 1 minus 3 plus 2, which is 0. So that is a root. Yes, because that tells me that it's a root. So then I have negative 1. Yep. So negative 1 cubed is negative 1 plus 3 plus 2 That gives me 4. So negative 1 is not a root. If I do 2, I get 8 minus 6 plus 2 is 4. So positive 2 is not a root. And then if I do negative 2, I get negative 8 plus 6 plus 2, which is 0. So that is good. So I figured out that I have a root at x equals 1 and x equals negative 2, right? So I have x equals 1, x equals negative 2. Now, what would my factor look like? If x equals 1 is my root, what is my factor? X minus 1, good. And then I would have x plus 2 as my other factor, right? Now, if I were to FOIL this out, right, I'd only get x squared, right? But we started with a x cubed, right? So that tells me that one of these factors has a multiplicity bigger than 1. So we can look at the calculator to see which one it is. If you were to FOIL this out, right, we figured out that we have a root at positive 1 and negative 2, right? If you FOIL this out, you're only going to get an x squared. But our equation is an x cubed. So we need another root. If you have an x cubed, you should have at most 3 roots. Well, we're going to look at the graph. Yes? Yeah. So you have to list factors of 2, which are 1 and 2, right? And then you list the factors of 1, which are just 1. And then to get these numbers here, you take this number, put it over this number. So 1 over 1 becomes 1. And then you do 2 over 1, which becomes 2. That's how you get your list of possible roots. This is your constant term. So that's the thing that doesn't have a variable. And then the q is the leading coefficient. So that's the number out in front of the leading term. You plug those into the equation. All right, so what you should put in x cubed minus 3x plus 2. So I have x cubed minus 3x plus 2. And then I'm going to hit graph. Okay, so looks like I got a root at negative 2 and positive 1. And which one has a multiplicity of 2? 1, right? See how it bounces at positive 1? Right, it goes right up to 1 and then it bounces right off of it. So that tells me that my multiplicity at 1 is 2. So when I write my equation now, I need to put a exponent of 2 on the outside like that. I haven't decided yet. Probably. All right, but that is how you do your rational root test. You have to list your factors. Yes. Right. Right. You have to look at the graph. All right, number 4. List the roots of g of x, and then use your calculator to help you decide which ones, if any, are actual zeros. Okay, so I have my constant term, which is 6, right? So what are factors of 6? 2 and 3. What else? 1 and 6. Good. And then I have my leading coefficient is 2. So I have factors of 2, which are 1 and 2. So you have to, again, your possible root is going to be this number over that one. So you have 2 over 1, which is 2. I have 3 over 1, which is 3. I have 1 over 1, which is 1. I have 6 over 1, which is 6. All right, now I did all of these with over 1. Now I have to do them over 2. So I have 2 over 2, which I already have, which is 1. I have 3 over 2. So plus or minus 3 over 2. I have 1 plus 1, plus or minus 1 over 2. And then I have plus or minus 6 over 2, which I already have with 3. So how many roots do you have, or possible roots do you have? 12. Good. Well, you can. I'm not going to do that. Say again, Jacqueline? Yes. Yes. Mm-hmm. Right. That's why you have negative steps. Exactly. Yep. Okay, so if you have a lot of factors to work with, like we do now, we had 4 before. 4 is manageable. 12 is a lot. So what you can do is put that into your calculator and then narrow it down. Okay, so I'm going to put in well, I wouldn't give you one where you had to test so many. So I have 2x cubed plus x squared minus 13x plus 6. Okay, so where does it appear that we have roots at? -3, +2, and what does this one look like? A half, right? Now, over here. Now, to make sure, I can use the calculator to help me out. So I can hit trace, which is this button up here, and then you're going to type in -3, and then hit enter. So it tells me when x is -3, y is 0. So that's good. And if I do that again, and I type in, say, 0.5, because that's a half, I hit enter, I get 0 again. So a half is also a root. And then if I do it one last time, I get 2. All right, so I do have roots at -3, a half, and 2. So okay, so I have roots at x equals -3, x equals 2, and x equals 1/2. How do you come up with the possibles or the answers? Yep, you just hit the trace button, and then you type in the number that you want. So it looks like I have an answer right there at 2, so I'm just going to type in 2, and then hit enter. So x equals 2, and it tells me that y is equal to 0. So 2 is a root. And then you would just repeat that for the other ones. Well, this is just one way to do it. There's many ways you can do it. I'm sorry? Just hit trace and then the number. You could do that too. That's another way you can do it. All right, if I have a root of x equals -3, my factor is what? X plus 3. If I have a root at x equals 2, I have x minus 2, and then I have x minus 1/2, right? Now, if I were to multiply that through, I'd only get x cubed. What did I start with out front, though? 2x cubed, right? So what I can do is I can just put 2 out front. Where? So if I didn't put the 2 there, right? You'd have x times x times x, right? Which is x cubed. You started with 2x cubed, right? So you can put that coefficient out front. Okay, so list the possible roots and then use synthetic substitution to help you figure out the actual zeros. Okay, so we've already done that. So if I have 20, factors of 20 are what? Plus or minus 10, plus or minus 2, plus or minus 1, plus or minus 20, plus or minus 4, and plus or minus 5, right? Now 1, right, because I have 1 out front of my x cubed here, is just plus or minus 1. So possible roots. I have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Right? 10 over 1, 10, 2 over 1, 2, 1 over 1, 1. You don't have to. You can put it really in any order you want. Just as long as you have the roots down. All right, so how many possibles do we have here? 12, right? So 12 possibles. All right, so another way that you can do this is using synthetic substitution, which we've learned from when we did dividing. All right, so one possible root that I could have is positive 1, right? So I'm going to see, does 1, if I divide 1 into my equation, do I get 0 as my remainder? So my coefficients are 1, negative 8, 11, and 20. All right, so I bring down the 1. 1 times 1 is 1. Negative 8 plus 1 is negative 7. Negative 7, 4, 4, 24. Okay, what is this? What does this tell me? Right, so this means that is what? Not a factor, right? So I gotta try something else. So let's try negative 1. So again, you still use the same coefficients. You bring down the 1. 1 times negative 1 is negative 1. Negative 9, 9, 20, negative 20, 0. So what does that tell me? Right. So I have a factor of x plus 1, and then what am I left with? What is this going to turn into? Very good. Now, if I factor what I have left, right, I have x minus 4, x minus 5. So my 3 roots are negative 1, positive 4, and positive 5. All right, so these are all 3 different ways that you can figure out your roots to your equation. So either just kind of just guess and check, calculator, or synthetic substitution.